Hello children, welcome to aimstoday online classes. In today's class, from physics subject, temperature topic we are going to discuss. So, from temperature lesson, some of the state level, nation level, previous Olympiad questions we are going to discuss today. So, in our previous videos, already some of the questions we have completed. Up to 10 questions we have finished already. We have explained already. Let's see the next question, 11th question. So here the question is, for a clinical thermometer, so we use a solid and a liquid. We use a solid and a liquid for measuring the temperature through clinical thermometer. The material we use, sometimes it may be a solid, sometimes it may be a liquid. The liquid used in clinical thermometer is what? Especially in clinical thermometer, always we will make use of a liquid material. So this is the thermometer. So here we will be having this portion. We will be having some liquid material which is called mercury. So here the liquid used in clinical thermometer is what? Is it a metal? Is it a non-metal? Neither a metal nor a non-metal. None of the above is correct. We are having 4 options here, children. But in most of the clinical thermometer, they will use of mercury, which is the only liquid metal. Metal means we might be knowing about steel, iron. These are all metals. Most of the metals are solids, but mercury is the only liquid metal which is used in thermometer. So the correct option is metal, children. So option A is correct. Next, 12th question. The range of laboratory thermometers is generally what? So in laboratory, for measuring the temperature of acids or some of the chemicals, for measuring the temperature of chemicals, so these laboratory thermometers are specially designed. For measuring human body temperature, clinical thermometer. If we got any fever, if we go to doctor, they will make use of clinical thermometer with less range. The range of clinical thermometer will be less because they measure only human body temperature. But whereas in the laboratory, while measuring the temperature of chemicals, some of the chemicals may be very cold. Some of the chemicals may be very hot. So the range should be more compared to clinical thermometer. So here the range is -10 degrees to 110 degrees. Means with this range, they can measure very cold chemicals and very hot chemical solutions. So the answer is -10 degrees centigrades to 110 degrees centigrades. This is the range of laboratory thermometer. Next, 13th question. The glass tube used for construction of a thermometer should be what? So whatever glass tube we are making use of glass tube for constructing the thermometer, it should have or it should possess what kind of properties? Means it should be long for calibrating the temperature, for noting down the temperature values. It should be long. And again, so it should be kept inside the solution. Or it should be kept inside the mouth of a person. So it should be narrow. It should be narrow so that we can keep in any object. And its construction type or area of cross section should be uniform. Means throughout the tube, its dimensions should be uniform. So the whatever glass tube we are making use for constructing thermometer, it should be long, it should be narrow, it should be uniform, it should possess these three properties. But we have D option, all of these, means this is the correct option. All of this is the correct option. Next, 14th, which of the following thermometers does not use mercury? Does not use mercury. In most of the clinical thermometers, we will make use of mercury. In some laboratory thermometers, we will make use of mercury. But in digital thermometers, there will be no liquid. In digital thermometers, they are specially designed so that we can carry them anywhere without any damage. So these are digital thermometers. In that, the mercury will not be used. So correct option is C option. Next question, 15th question. The flow of heat by conduction. So conduction is a process of transfer of heat. In transfer of heat, we have three types: conduction, convection, radiation. We have three types here. So here conduction means the heat passing through this solid object, this rim of the vessel, this handle of the vessel. Because we have taken a vessel or we have taken a beaker here, which is having some handle, and with the burner, we are supplying some flame to this beaker. So this beaker gets heated, the liquid inside the beaker gets heated, the handle gets heated. So here, the conduction. So here handle, it's a solid actually. This conduction means the heat transfer without any movement of molecules. That type of heat transfer is called conduction. This conduction we can mainly observe in solids. So question is, the heat by conduction observed in, answer is solids. Next, 16th. So in which of the following ways heat flow from one body to another? So here a handle is a solid. We can observe heat transfer in solids through conduction. Here this liquid, we can observe heat transfer in liquids through convection. Here this flame will go to the surrounding air and it will make the surrounding air hot, which is a gas. That process is called radiation. So heat transfer, it can happen by conduction or convection or radiation. It can happen in any way. So answer D option. All of this is the correct option. So which of the following ways heat flows from one body to another body means correct option is all of this. D option is correct. Next. So consider the figures of metal ball and metal ring given below. Here, this is the metal ball, this is the metal ring, these two are. This is metal ball, this is metal ring. These two are given here like this. The metal ball can just pass through the hole of the metal ring formed out of a strip. This metal ball, it can just, this metal ball, it can just pass through the hole of this ring, which is formed by strip. Next, here when the ball is heated, if we heat the ball, we cannot pass through the hole in smooth manner, but it gets stuck. It gets stuck when it gets heated. The ball gets heated, so it gets stuck in the ring. But when the metal ring is heated, what happens? When the metal ring is heated, this normal ring will expand. Now the ball can pass through the metal ring. So first, when the ball is heated, it gets struck. But when the ring is heated, the ball now can pass through the ring because ring diameter expands on heating. So ball can easily pass through the ring. So option B is correct, children. So here, children, next 18th question. To keep correct time in watches. Correct time in watches. This is the inside part of a normal wristwatch. Normal wristwatch or wall clocks. This is the inside part. Means all the minute hand, second hand, hour hand, all wheels, they will be like gears. So this is the, see here, a second hand, hour's hand, minute hand. This is the main spring, main wheel, click, winding, pinion, hairspring, balance wheel, jewel, pallet, escape wheel. Like this, they will be having so many parts. In this, we are having balance wheel here. These balance wheels are made with what? Just now we have discussed all the materials will expand on heating. Will expand on heating. So that expand on heating is called expansion on heating is called thermal expansion. So our wristwatch or our wall clock, it will be in continuously under the effect of hot conditions. If the climate is very hot, the wristwatch also will become some hot. But during that hot conditions, with what kind of material we have to make the balance wheel, so that thermal expansion will be very little. Very little. So there will be no change in time. There will be no change in time. So if there is no expansion in the balance wheel, there will be no change in the time. So in all the watches, the balance wheel should be made with one kind of material whose thermal expansion is very less. So out of this steel, invar, platinum, tungsten, this invar material, which is an alloy of nickel and iron, which is a mixture of nickel and iron, this possesses very little thermal expansion. Means though we supply heat to this balance wheel, but the expansion is very small, which is almost negligible. So that we can find accurate time through the watches. So the balance wheels are made with invar. So here, children, A, C, B, D. It's printed in wrong order. Invar material is the correct answer, children. Next, 19th. The coefficient of linear expansion of solid depends on. So here, linear expansion. If you see here, for aluminium, this coefficient of expansion per degree centigrade, it's 25 somewhere. 25 into 10 power minus 6 is there. For brass, 19 into 10 power minus 6. Brick, copper, glass, glass plate, and glass pyrex. For different kinds of substances, we have different coefficients of expansion. From this, what we can tell? So, coefficient of expansion of a solid depends on nature of the material, whether it is made with aluminum, brass, brick, copper, glass. Depending on the kind of material, this coefficient of expansion will be different. So it depends on nature of material. So this amount of linear expansion may depend on its original length, rising temperature, initial temperature. But we are not asking here amount of linear expansion. We are talking about coefficient. It depends on nature of material. Next question, 20th question. While laying telephone or electric wires, a little sag is left because little sag means they were loosely fixed. They were loosely fixed. Why they were loosely fixed means so that they can contract during the winter. If they are tightly fixed, if they contract, this will break. This will break. So that's why they are loosely fixed. So it is a little sag, looseness is left because to contract in winter. To contract in winter. So option B is correct. Next one. 21st question. In the process of flow of heat by conduction, flow of heat by conduction. So, one minute. So, conduction. What happens here? There is no movement of substance. The heat transfer takes from higher temperature to lower temperature. Occurs when one end of iron rod is heated on a burner. All three are correct, children, because here we are using a stick here, agarbatti stick. It gets heated, but we are not moving the stick here actually. So directly it gets heated. There is no movement of the substance. Without the movement of the substance, the heat can pass through all parts of the agarbatti stick. And one more thing, heat transfer takes place from higher temperature to lower temperature. First, this parts get heated. It will be considered as a part of higher temperature. Then moves to this part, which is considered as lower temperature part. So it moves from higher temperature to lower temperature. Not only this stick, if you take one iron rod, if you keep one burner, so if one end of burner is heated, one end of iron rod is heated on a burner, the other end also will become heated because heat transfers from higher temperature area to lower temperature area. So this process is called conduction. So all the three are correct. So D option is correct, children. Next, children. Here. So bimetallic strip. Bimetallic strip means two metals. Here, black color, whatever you are seeing, it's a combination of two metals. It's a combination of two metals. So what it will do when it becomes very hot, it bends towards the metal. It bends towards the metal with higher thermal expansion coefficient. When switch is on, after sometimes it becomes very hot. So this bimetallic strip bent towards the metal with higher thermal coefficient expansion. So here this circuit will break. There is some gap will come. Here some gap will come. This circuit will break. Again it will become cool. Again it will become cool means it will bend away from this metal. Bends away from this metal. Again circuit will make. Again bulb will glow. Again it will become hot. Like that, it's a continuous process. We will observe this bimetallic strip in electrical appliances. Though we are continuously supplying the electricity, but the electrical device does not get heated continuously because of this bimetallic strip. Because of this bending towards the metal, bending away from the metal, the circuit will break or make, and the heat content will be maintained in a stable manner inside the electrical appliances. So answer option B, bends towards the metal with higher thermal expansion coefficient. So okay children, remaining questions we can learn in our next video. We can discuss in our next video. So thank you for watching our video children. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you children. Have a good day.